Alright, this is the video on the first example of the telescope section in chapter 5. So the first example is question 109. So as always, let's read the question first. Question 109. A small telescope has a concave mirror with a 2-meter radius of curvature for its objective. Its eyepiece is a 4-centimeter focal length lens. So part A, what is the telescope angular magnification? Part B, what is the angle subtended by a 25,000 kilometer diameter sunspot? Part C, what is the angle of its telescopic image? So first, let's write the relevant piece of information. We are told that basically it is a reflective telescope because the objective is a spherical mirror with a radius of curvature of 2 meters. We are also told that the eyepiece has a focal length of 4 centimeters. Now, I'm always converting these into meters, so 0.04 meter. Part A, we are asked, find the magnification of this telescope. Now, because it's a reflective telescope, the magnification is equal to minus the radius of curvature divided by 2 multiplied by the focal length of the eyepiece. We plug in these values and we get minus 25. By the way, there's no unit here. It is a ratio. It's a ratio versus the angle of the image divided by the angle of the object. All right? In part B is a bit different. We are told what angle is subtended by 25,000 kilometer diameter sunspot. So let's draw a simple picture here. We have the sunspot here. We have to assume that it is spherical over here. Now, by the way, as always in a test, this will be specified. So we assume that it is a circle or a sphere in this case. We are told the diameter over here of this sunspot. Now, this diameter is 25,000 kilometer or 25 million meter. Again, I'm switching into meter. I think it's easier that way. Now, we want to find this angle over here. We can imagine that our telescope is over here, and what will be its angle from the sky? In this case, we can form a right triangle, as is often the case in this course. And basically, this here will be the radius of our sunspot. Now, we need to use a trigonometric function which make the link between the opposite side and the adjacent side. In this case, it will be the tangent. But first, we need to find the height over here, which will be the radius of the object. Radius of the object is simply the diameter divided by 2. So in this case, it's equal to 12.5 million meter. 12.5, so 1.25 multiplied by 10 to the power 7 meter in this case. Now, here, this value over here is the distance of the object. It's not specifying the question, but we're talking about the sun. And the sun, so DO is equal to 1.5 multiplied by 10 to the power 11 meter. So a very big distance away. Now, the angle of the object is equal to the inverse tangent of the radius of the object divided by distance of the object, and it's equal to 0.00083 degree. Now, one thing I want to mention, in the note, they use the small angle approximation, and this will work here. This is a small angle. However, you have to be careful if you use the small angle approximation. Your value would be in radian. Okay, so be careful with that. If you don't understand that part completely, simply use the tangent. It's easier to use. All right. So this is part A and B. I'm gonna erase part A, so you can pause the video. I need some more room to complete part C. All right, so part C, this one is rather simple. What is the angle of its telescopic image? Well, magnification is equal to angle of the image divided by angle of the object. We just found the angle of the object. If we combine everything, we got angle of the image is equal to minus 25 multiplied by angle of the object. And it's equal to 0.00208 degree. Now this one is a bit messy, but you get the picture here. All right, so we've got one last example which use some slightly different trick we're going to consider. But all in all, there's nothing really new in telescope. All right, same logic we've been using since the beginning of the chapter.